Hey everyone. So today I have Daniel on the chat or on the live stream. He's a University of Waterloo student. Could you just give a quick background on? Yeah, I guess you go to University of Waterloo. Like, what year are you in? What companies have you worked
Sure.
for? Maybe what companies are you aiming to try to get into when you graduate?
Sure. Yeah. Hey everyone, my name is Daniel. I'm a third year software engineering student at the University of Waterloo. I've completed around 180 leak code problems. I'm going to be interning at Stripe this summer,
Nice.
and in the future, I'm looking to kind of break into more big tech roles. So, kind of just trying to get some practice in through mock interviews.
Nice. Yeah, Stripe is a really good private company. Are you trying to break into like fan companies too, or you want to stay at like Stripe level companies?
I think I've worked at like Stripe is gonna be my second unicorn, and
I
then
see.
I have something lined up for fall as well. So that's gonna be my third unicorn.
Wow.
Hopefully, I kind of want to try out like working in big tech as well. So yeah, definitely try to transition into Fang at some point.
What's your next unicorn, if you don't mind sharing?
It's gonna be Verkada.
Oh, nice, 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 nice. The camera company.
Yeah, yeah.
Are you gonna be moving to the states at all, or it's all like in Waterloo?
So Stripe is in Toronto, and then for Verkada, that's gonna be in San Mateo.
Cool. So, what do you think your leak code skills are at right now compared to maybe your
I think
peers?
I think my Lico skills are like average. Like I've done Lico style interviews before, and I think I've like held up decently. But for most of my like interviews at unicorn companies, they weren't really Lico style, so I kind of want to prepare myself for more like big tech
I
interviews.
see. I see. Okay. I see. I see. I see. Okay, we're gonna get to the first questions then. It's like let me pull up. So how we're gonna structure this interview is pretty much we're gonna ask you two questions. You have about 20 minutes, 20 minutes for each question. We're gonna try to keep it around 45 minutes for the whole interview, and yeah, like when we hit about the 20-minute mark for the first question, we're gonna move on to the second question. Just yeah, don't mind if I interrupt
Sounds
and we
good.
move on to the next question. I'll give you feedback at the end to see where you're at and let you know where you're at. Um, okay. So I'm gonna post the first question in here.
Okay.
So yeah, I'll let you go ahead and read this question and clarify every like all the requirements and stuff.
Okay. Um, I'm just gonna take a minute to read through the problem.
Go ahead.
Cool. Okay, so after reading the problem, it seems like we have an integer array of n buildings, and then each building is, or the value at indice I indicates the height of the building, and then we're gonna have an ocean to the right of this list, and we basically want to output um, a sorted or like in order what buildings have an ocean view.
Yeah, exactly.
Um, just to clarify, like if two buildings are the same height, then the one that's comes before on the left wouldn't have like a view, right?
Yeah, exactly. Like if a building is just as tall as you, you're not gonna see anything, right? You have to be taller than it at least.
Yeah, okay, cool. So I think off rip, my initial thought is, wait, hold on. if we have like a building of height, is it possible to have a building of height zero?
Nope. Every building
Okay.
is one or more. Zero means it's no building there. But let's say every
Yeah.
building
Okay.
is at least one story.
Got you. Got you. So I think like what comes to mind initially is we can just start from the back and then iterate to the front of the array, and then we can maintain like the highest building we have so far. And
Okay.
then if we have a building that exceeds the height of the previously highest building, then we can just say that yes, this building has a view of the ocean. We can store it in our solution array.
Hmm.
Um, and then we can update like the variable that keeps track of the highest building we've seen so far. Um, and then I guess we're just adding these indices in order to an array. Um, and this would also keep it in like a sorted order, so we can just return from there. Um,
Okay. Can you
would
wait?
you
Can
like
you
me to go
walk?
through like a
Yeah, walk me through a small example here of like.
sure? I'll just go through the first example.
Yeah.
So basically, we have like some ocean, which is like here,
Sure.
and then we have like some buildings of certain heights here. So if we're gonna walk through this input, then we basically have like one obviously can see the ocean because previously we have maybe like a beach that's height zero.
Yep.
Um, so we would have like zero, one, two, three, and then three is higher than one, so three also has a view in the ocean. So we just have two here, and then two doesn't exceed the highest height we have so far, which is three. So two would not be added to our solution. But then when we move to the last element in our input array, we have four, which exceeds the maximum height so far of three. So we would have to add this index as well to our solution. So the answer would be 0, 2, 3, which are the three buildings that can see the ocean, and these are also sorted by increasing or in increasing order by indices.
Uh huh.
So I think I'll type my. I'm gonna begin. Does this? Sorry. Does this approach make sense?
Yep. That makes sense.
Okay, so I'll just type this out kind of LeetCode style.
Sure.
Constellation def. Uh, we'll say like find find ocean view, and then we'll do as well as well as I guess yeah, that's all we're taking in. So can do like a for loop, or we can initialize to our max height. We're gonna initialize to 0, and this is basically gonna hold like the max height of a building we've seen from the right. Um, and then we can iterate backwards. So we'll do like for ind x or height in enumerate buildings. We'll do like we'll have this reversed. So we'll do if the height exceeds our max height. If the height exceeds our max height, then we can add the indice of this building to our solution array. So we have to define like a resulting array. Do red dot append ind, and then we'll do max height equals height. And then let's see, what order would this return? What would our results array look like after this? I'll just put this here for now. If we go through backwards, the indices are going to be reversed, so I guess we have to account for that. So we'll do like
What does this do? Does
and
this create a copy of the buildings and actually
is
reverses it?
yeah. I think like I think we could also in Python, there's like you can use like the reverse keyword, but I don't know. This is the way I know how to do it. Like this just creates a copy in reverse order.
I see. Or like,
So
why not just use an index and go backwards? Have an index.
yeah, that's true. You're right.
Yeah.
We can do like in
Yeah,
range
because
of
if it's like a
n, and then
massive array, it's like I feel like it's a bad way to like go backwards on an array.
yeah, if we make an entire copy, right? So yeah, that's true. So we'll just do like buildings, uh, n minus minus one. All right, so instead we're gonna iterate backwards using an index, and we basically just compute like where the matching index is at the back of the array, um, and then we want to append this and not the actual index. Um, we can access our height using this, and then if the building exceeds our max height, then we should append this index, and then set our new max height to this height. But what order are we appending our indexes in? We have to return like our resulting array in reverse order, I guess, since we're going from the back to the front and we're appending. Um, yeah,
Sure.
I guess like this is not it's not clean to like make a copy, but like I think it's like O of n to just insert into the front of an array
Yeah.
because like
It
the
is all
problem
then.
here is like yeah. Um, so I guess we can just return a copy of our results. And in terms of like runtime, or did you want me to like run through a
Yeah.
test case
Yeah.
with
Do
this
do a
building?
dry run. Dry run.
Sure. Um,
With
so
this
we'll do
example
like
again, and like trace your code
yeah,
along with it. Sorry.
okay. Result is this. Uh, we'll do like but or let's see what it prints out.
Or we're not running the. Let's not run the code. We're gonna dry run it. If like, walk me through how the code is and like store all the variables.
Oh, okay, yeah, got
Dry run it
you.
from
Okay,
scratch.
yeah, okay. So, like, if we were to input the buildings into this method, we're gonna first start by initializing our like our max height as well as our n like the buildings. So we're gonna first compute the number of buildings. So we have 4 buildings, and that's gonna be passed into n, and the result is initially going to be empty. We're gonna iterate through each index from 0 all the way to n, and then we're on the first iteration. We're gonna say the height that we're examining is equal to well 4 minus 0 minus 1, so that's going to be 3. So we're going to be looking at the last value here, which is 1, and then 1 is going to be I'm actually going to adjust this since I already computed height. Since 1 is greater than the max height, which is currently set to 0, we're going to record this index, which is going to be 3 inside our resulting array. So we append this 3 here.
Sure.
Um, we append this 3 here, and then we set our new max height to the height of the building we're looking at, which is 1. And
Sure.
then on the second iteration, we have int equals 1. So the index that's passed into here is going to be 2. And we're looking at this building right here, 3. And then 3 is going to exceed 1. So we're going to add this index here. And then our result is going to hold 2. Yeah, sorry. Yeah, it's going to hold 2. And then we're going to set our max height equal to 3. And then on the third iteration, we eat in a building 2, or our index is now 2, and then we're going to access this building, which is of height 2. But since 2 doesn't exceed what our max height is, which is currently 3, we're not going to do anything on this iteration, and we're going to move on to the next. And then now our index is 3, so the height that we're going to access is the first one in our input array, which is going to be 4. And since 4 exceeds the max height of 3, we're going to add the index here, or yeah, we're going to add the index here, which is going to be 0. And we're going to set our max height to 4. So that's going to be it for our loop, and we're going to exit it. But now our res is 320, which is the reversed order of what we're looking for. So we make a copy and return the reverse order. So res turns into like 023 instead, which is what we're looking for.
Okay. Um, what's it called? Let's see. Yeah. Makes sense. What's your time and space complexity?
So in terms of extra space, or sorry, in terms of time complexity, we're doing O of one operations within our loop, and we're iterating n times. So it's going to be O of n. And then in terms of space complexity, we're going to need an extra variable to store like the length of buildings max height, but this is negligible compared to our resulting array. And I guess worst case scenario, we have like all n buildings are able to see the ocean, so the space complexity would be O of n.
Spaces and okay, cool. Let's move on to the next question.
Sure.
I'm gonna drop it under this. Okay. This one's I'm gonna explain this to you because it's a bit more um, wordy.
Okay.
So we're pretty much gonna be given a list of accounts, right?
Okay.
It's gonna look like this. This is the input. So we're gonna be given a list of accounts. This is account 1, account 2, account 3 here. So the first
Okay.
element is the name of the account, and then they have a bunch of emails, right? So what
Okay.
we so yeah, I'm just gonna post in the rest. So it's a name. Each element is a name, and the rest of the elements are emails. So we want to merge the specific account, right? And
Yeah.
we want to merge accounts that belong to the same person, and they belong to the same person if they share email. So look at 54 and 55. Are these two accounts the same?
Yeah, these two are the same because they share this johnsmith@mail.com.
Okay. What about? Oh, sorry. What about this last guy? Is he the same John as the other one?
No, he is not the same John because he doesn't share any common emails with any other John.
Okay. So basically, what we need to do is we need to output the final result here, like this, where you see how, in the first one, we have
Yeah.
yeah, you see what they're asking here, right?
Yeah.
So the first one is the first John, but now all of the or their accounts are merged. The next one's Mary, and then the third one is just John, but it's not the same John as the other one. So write an algorithm that can take a bunch of accounts and return this as the output.
Okay. So like, just to clarify the input, would there ever be the case where like, or I guess what would happen if like we have like a John with john00@mail.com, and then maybe Mary also has an email named john00@mail.com. Is this like a possible input?
No, like a person can have any number of accounts, but all of their accounts have the same name.
All of their accounts have the same name. Okay. Gotcha.
Like this, it won't be the case that Mary has like John here.
Yeah. Okay. Um, I'm just gonna take a minute to think.
Sure.
Um,
What are you thinking? Like what comes to mind?
yeah. So like when looking at this problem, it looks like we need to use like something, well, operations to its sets, and then maybe like union them, or like finding like what if they even have any elements in common, and then if they do, like we want to merge them kind of. But like if I want to process this input, what I can do is say like if we've seen if we go through every email, and then if we've seen this email before, we can find like the account that is associated with, and then immediately just append all remaining emails that's associated with this name into that existing account that we have. Um, but is I'm just wondering like how we might be able to do that. Like if we had like a dictionary where we have like an email, where the key is an email, and the value might be um, a user ID or something, just so that we can avoid like overlapping Johns that might be different. Um, so like for example, this if we process this account first, we might have johnsmith@mail.com associated with like user ID one, which is a John, and then we also associate this email with that. And then when we come to process this account, we see that we have johnsmith@mail.com again. So we have an existing associated like user value. So any remaining emails should just go into this account, and then we can kind of organize it into a data structure in this manner. Um, does this approach kind of make sense to you?
So you're gonna be using a hash map or like what are
Yeah, I'm gonna be using a hash map with the key as like an email, and then like the value is going to be like a user ID, and then we also maintain like maybe a user ID to a name.
okay?
Uh,
Can you walk me through that? I still don't completely see if it's gonna work.
yeah. I'm not too sure myself. I'm just kind of thinking out loud. Um, so like if we were to go through receive this account input, we want to kind of process these in order, and then we're gonna first identify that we have some user named John, and then we're gonna go through like all of his emails and then see if we have like an account that is associated with this email prior. And if we do, we're just gonna immediately add all remaining emails to like the set. But if not, then what we should do is assign a new user ID to John, and then say like, okay, one is John's user ID, and these are his emails. Um, but like I guess this doesn't work because if we have like let's say we have like John with johnsmith@mail.com and John_New York@mail.com, and we eat in another John with like sorry, I'm just gonna reorganize like this or copy this input. This is demonstrate an example. Uh, if we have like three John accounts, and the first one has johnsmith@mail.com, and the second one is also like John with this email, and then we eat in this third account, then I guess we would have to merge these two existing accounts if we were to use like my approach. So I guess this doesn't work. Um, does that make sense?
Yeah. So what are you thinking? Yeah,
I'm not.
just keep thinking, just keep going. Like I like how you're thinking.
Yeah, yeah, yeah.
You just need to get to the approach. Like you're making
I think
some
like
progress.
yeah, yeah. I think like something that would work is like if we have like if we consider it as like a graph,
Sure.
we can say like
There's
if
a
we've seen
whiteboard
this.
here too, by the way.
Oh yeah, okay. So So if we have like this, oh, this is cool. So we have like a John here, and then we have, or sorry, if we have like johnsmith@mail.com, we know that like this belongs to like, let's say it belongs to this blog. And then if we have like a john00@mail.com again, we know that there's like another blog. And then if we have this third account that's in this like input over here,
Yeah.
and we have johnsmith@mail.com and John underscore New York mail@mail.com, we
Mm-hmm.
can kind of like make the association where we draw like, okay, have already seen both these emails and uh, they point to these accounts, and then we know that like later on we're gonna have to merge all of these together. So like I guess we can maybe construct like a forest from that, and then union all the emails that of associated accounts, and then find like all the accounts combined together. Does that kind of make sense?
Okay. So how are we gonna construct this forest? Like I posted down here. We have
Down where?
like how are we gonna construct this forest? I just need more specifics on that.
Yeah, yeah. Okay, so I'm just gonna take them. Okay, so like let's say we have a bunch of accounts as inputs. We're
Yeah.
just gonna immediately make like associated like identifiers for each account, and then also say like, I'm it's kind of tricky. Um,
Which part?
um, I don't know. This implementation that I'm thinking of seems like way too complicated for what the question's asking. So basically, I want to just have like an associated like account number for every account that I eat in, and then every time I also want to populate my hash map with like an a email and what account it's associated with. And then basically whenever I see a new email, I want to see like, do I have this? Have I had this email before? And if so, then I'm gonna point my account to whatever account belongs to that. And then in the end, I kind of want to like do a graph traversal of each tree or like each component in my graph, and then merge all the accounts or merge all the emails into one account. But like, I don't know, it just seems like overkill for what the problem is asking. I'm sure like there's
I mean, you're going to
a better
the
way.
right approach, but I'm just not understanding the ID part. Like just could you just repeat that and be more specific?
Like, let's say for every account, we want to
Yeah.
eat in because since these names aren't unique, like it's hard to make an identifier for like an account. So every account that we eat in, we might say like this first one is one, second one is two, third one is three, fourth one is four, and so on and so on.
Sure.
Um, so then later on, like if we want to point an email to another account, we won't have to say like this is pointing towards like John. If we have like multiple Johns, if it's pointing towards like account four, and we know exactly what account four like represents, then we can like extract the contents from there and then merge the emails.
Okay. I think the ID part. I mean, we can get to it, but like, how are you gonna figure out which emails belong to each other? Like, which? How do you group the emails? 'Cause that's essentially what the problem is asking, right?
How are we gonna group the email?
Exactly. Because we need to return a group. Like, in the final output, we need to group all the emails and then just assign them John. Like, I mean,
Yeah. Um, I'm wondering like, is there a way we can like maybe sort the inputs so that we can ensure that emails can or like we can have like a larger group come before a smaller group so that way we're not like when we merge later on we're not creating like two divergent groups Um,
Let's just work through a very small example, right?
okay.
Let's do this example right here, but let's move like what should be the output here, right?
Yeah, so the output for this is John's. The output for this is going to be like a solo account for this John, and then this John is going to merge with
Oh,
this
sorry.
John as well.
Let me add this.
Yeah, so
What would be the solution?
the solution for this would be like all the Johns mixed into or merged into one account. So it'd just be like John with the John Smith email plus the John underscore New York plus the
Okay.
John00 at mail.com account. Um, I think like maybe what we can do is like basically whenever we see an email that we've seen before, we're gonna merge that account into ours. So then that way, like if we ever have the case where we have like this smaller account, then this other smaller account, and then this bigger account, we can just when we reach this, we can populate this bigger account with, or we can just get rid of the smaller account and get rid of this other smaller account by like union merging the sets of emails from the previous accounts.
Okay.
So I think we can kind of do that as we go along.
Okay.
Um, maybe I might like write out like a little blurb of text just
Sure.
to explain kind of what I'm thinking. Um, so basically, for each input account, associate email account uh, for each new input. If we see an email we previously processed, merge that account into ours. Merge that account into ours. So I kind of want to now think of like how I want to do. So merge that, and then at the end we should have a hash map of accounts with unique emails. Process that to formatted accounts, and then like implementation you can use like use map email to an ID in one of the maps, and then the ID mapped the ID to
Yeah.
a list of. We can do like
Seems like you're like
tuple.
thinking of like a union find or something. Are you
Yeah,
familiar with that at all?
yeah. Union find like it's
Have
a
you
union find
implemented it
supports
before?
like I haven't implemented it before. Like I'm taking algorithms right now, so we like kind of learned about it last month, but I guess I didn't study hard enough for that data structure.
I see.
Union find has like a parent, like find if it has a parent, and then like union two different components within a graph, right?
Yeah. I mean, let's go back to the drawing
It's like
board. Like,
yeah,
what is there a way that we can think of this as like a graph? Pretend we have like three different. Pretend I'll just give you a like. Let's remove these emails because it makes it harder.
okay,
Pretend John has email one. John has email two here,
yeah,
and maybe three.
uh,
And then we say this other John has email three and 5. If we think about this as a graph, right? We have one John with
Yeah.
email 1, one with email 2 and 3, and another with 3 and 5, right?
Uh huh.
You see how um, like building a graph might lead like how many different accounts will be here?
It's just gonna be like two accounts,
Yeah, and then like which ones
like
belong?
John
Yeah,
one.
yeah.
Yeah, but I'm not like, to be honest, I'm not familiar with like the implementation of a unified
I mean,
data structure.
this would just be like a simple DFS, right? Like finding connected components in a forest.
Oh, you're right. Yeah. Yeah, so I guess like we could just go through all the accounts. John. And then like, so I guess like every email can like branch off into whatever accounts they're associated with. And then we basically just have to DFS like starting from any given email and then identifying like every component within that section of the graph. Does that sound right?
Yeah. So yeah,
Mm.
how are you thinking of like parsing out? How are you thinking of building up this graph?
Um, I think like we're gonna have to have a data structure that associates emails with different accounts, and then we basically like after we parse our input and then make these data structures, we can just start from. Hold on. I feel like running a DFS, like I'm not super confident on like how I would approach like this DFS solution. I feel like the solution that I was kind of writing out before has like a similar complexity, like runtime.
Mm-hmm.
I don't know, like is there or do you see any like edge cases that I might not be catching in the way that I was looking to process it before?
Okay, could you just quickly explain again? Because it
Yeah,
didn't. Yeah,
sure.
I thought you were going the wrong direction, so I just wanted to give a hint if you want to
Yeah,
try this
so
out.
yeah. Um so basically we receive like a list of accounts and then we're gonna assign like an ID to the account initially.
Yeah.
And then when we see we're also gonna say like this email is mapped to this account, and then we're just gonna go through our array this way. But then when we see an email that we've seen previously, then that means our map is gonna be able to identify like an account that we've seen before. So we're just gonna immediately merge that into here, and also at the same time update this email's account value to our current account and maybe like all accounts associated with this previous account. And then we're just gonna traverse like this way, and then at the end we're gonna have basically a map where um, each we're gonna have like IDs that are we're gonna have like a map of IDs to like whole accounts
Okay.
that are like
I
merged
see.
with all associated ones.
Okay. We have about 5 minutes left, so let's just get to coding it, and then let's see where we get to.
Sure. Does this kind of make sense to you?
I think so. Let's see the implementation and see.
Okay. Yes. and then we'll do like. Alright, I guess CoderPad doesn't really like this typing type. It's more like legal style, but I can just get rid of it for now. For account and accounts, we're gonna have to identify like email, email. For an account and accounts. The ID is going to be email to account of this email equals ID, and then for email and emails, and then ID to account of this ID is going to be equal to the set of emails. We'll make it a tuple for names, or we can't put a set in a tuple, so we'll do like a list. Names, set, emails, and then email to account. Every email is going to be associated with this ID, and then after this, we're going to have to increment the ID. But like this is just the processing part, so I guess we also need to account for like the implementation that we thought of earlier here. So if we have an ID that we've seen before, so for email, before we can even do this or create a new account, so for email in emails, we're going to have to merge all previous accounts with the email. We'll do like if email to account, if email in email to account. If we have an account that has the email previously associated, we need to do identify the account existing ID equal email, and then for this account we have name, emails, existing emails.
Wait, what's emails here?
For email, oops, I just accidentally. So emails is like the name is the first element, and then emails is gonna be the remaining ones inside of the list. And then basically here is like for every email in this account that we're eating in, if we find one that we have like a previous one associated to, we're gonna identify the existing ID, and then we're gonna say like the name and the existing emails are gonna, the set of existing emails is gonna be equal to the value of this existing associated with the existing ID. We have to put existing name ID to existing. So for all these existing emails, what do we need to do? We need to first delete the previous account. So email for delete the existing account. So ID to account dot pop, and then we're gonna have to merge all of these emails from this set into the emails coming into this new account. So we can do uh
Okay. Okay, we're at 45 minutes, so I'm gonna stop you there.
yeah,
Um,
I think like okay, looking back at the problem, this is definitely like not as optimal as doing like a traversal, but
mm,
I think like it still should work.
I see. Yeah, I think I'll have to look for if there's an edge case. It might TLE, that's the main thing, but how do you think you did
I think it
overall?
would TLE. Um, I expected myself to like be able to solve both problems. The first one was like a warm up. Um, but this problem was definitely a lot more challenging.
I see.
Um, I'm kind of disappointed that I wasn't able to get like the DFS or like identify that it's like a graph and we need to do like DFS on all the components. Um, I wish I would have like communicated my thought process more. But overall, I thought I did decent.
Yeah.
I know your scale is like 0 to 4, and I
Yeah, what
think
do you give
I'd
yourself?
probably give myself like I'd probably give myself like a 3 at best.
You're at best. Yeah, I think this one, I mean, it's hard to say because okay, let's talk about everything. I think Q1 definitely really easy. Like you solved it really easily. Um,
Hmm.
it's not some people I like. It's not the. I mean, it's an easy question, but it's still a medium, so it's still a good job on it in general. You're able to figure out. I think there's just like some weird syntax with like. I mean, like why not just use something like range here, right? Like going
Up
backwards on
here.
it. So like, I mean, this still works, but it's like a bit more convoluted.
Yeah.
And then what else? Oh yeah, somebody said like your solution might not Q2 might not work because of cycles, but let's focus on Q1. I think yeah, there's just like also with reversing. Why not just like call like the reverse? This is like kind of a nit thing, but like reversed and reverse are functions that they created on arrays that do exactly that. Like you're using slicing in order to flip it,
Yeah, yeah,
but like it's just more convoluted. I would say like why not just use the function that's already built in?
yeah, yeah. I guess like at this step, I think I should have just looked up the syntax because I knew that like this existed, but like I just went with the way that I knew, like to reverse
I see.
because
Okay.
this would like create a copy and like use extra space.
Yeah. And then when you're one another tip would be like when you're trying to point at a specific element instead of highlighting it, you could just use a caret to just point at the specific one and then work backwards.
Yeah. Okay.
That's a small thing, but overall, honestly, you're a good you're a solid yes on the first question. Like you
Okay.
clarified everything well. You wrote really clean code, and you did a dry run really well, talking about all the variables and what where they're at, and then like built up the
Mm.
variables like you basically compiled the code and like basically I want you to be a compiler when you're doing the dry run and that's what you did. Like you walk line by
Yeah.
line, you didn't skip any lines, so I'll give you a solid yes. Second question, I think just need more practice, like figuring out identifying when it's a graph question. Like it is a
Mm.
harder medium than usual, but it's still like a medium. I think yeah, when you get to work doing harder questions, this is a valid interview question. Also, like I've seen this been asked,
Yeah.
so
Yeah.
I think identifying it's a graph question um, would help you there. Like I couldn't say that you. I think yeah, definitely it would just be more practice. Like you obviously know how to code. You obviously know like, are I just don't know if you were making good progress towards the question though. Like I didn't think
Yeah.
like I think you wouldn't have known it's a graph question unless I said it there.
Mm.
Like on the interview, maybe by yourself you would have done it, but like yeah. So I would think I honestly this would all depend on how many people actually got it right. But if more people got it right, then I would probably it would be a 2. But I think since this is
Yeah.
hard,
Yeah.
I actually don't know if I got enough signal. So I'd probably make you have to do a follow up But I think
Okay.
a lot of candidates would actually like 30% would figure out it's a or 40% might figure out it's a graph question. Like, I think why I'm leaning towards a no instead of yes because you didn't notice it's a graph problem,
Yeah.
and that part would be like if you figured out it's a graph problem but couldn't implement it, then I'd lean to a yes. But I think you're just not at the
Mhm.
right solution. So yeah, that's why I would like lean to a no. Does that make sense?
Yeah, no. Yeah, yeah, no. It makes sense. I'm
Yeah.
like, yeah, I'm kind of disappointed that I didn't like identify that,
Yeah.
but it's
Awesome.
just comes with practice.
Yeah. No,
Anyways,
you're good. Yeah. Hit me up as always. We could do more of these. Um, cool. Thanks for taking the time out.
yeah, no, thank you for your time, James.
Yeah.
I yeah, I'd like to book like another slot sometime.
Well, yeah. I'll
Is
you have me
Can
on
you like?
LinkedIn. Just message me, and yeah, we'll do other questions as well. That's fun.
Sure, sounds good.
All
Anyways,
right.
thank you.
See ya.
Yeah.
Yo, chat. How did I go? 11 hours. How was that? That was my last interview for the day. I'm gonna go eat some dinner. But I hope y'all learned a lot of stuff. Yeah, I got work tomorrow, but I'm feeling good. I'm gonna go eat some dinner, and then I'm gonna go grind tomorrow too. We're gonna put a. Don't worry, I still go hard at work, but I probably yeah. There's gonna be more stuff on the weekend. All proceeds are going to Coding Jesus paid course. Shout out to everyone who jumped on the stream. Everyone was actually really good, which was fun. I think everyone learned a lot of things. But yeah, I'll catch y'all on the next stream. We'll definitely do this again. I have a ton of people from all types of different schools. I have like a Netflix guy. I have like some quant guys, like bunch of different people that I could put up on this like do interview style. But overall this was fun. I'll see y'all in the next stream for sure. Let me close this out. Thanks for tuning in. And thanks Shabaj for another $11. Appreciate y'all.